alaikum wa rahmatullahi wa barakatuh. Peace be upon you all and welcome to the channel. In this video we will continue where we ended in the previous lecture with the string method or the string class here, and then we will continue with the diagrammatical representation of the dynamic array. But before we begin, بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه ومن تبعهم بإحسان إلى يوم الدين وارض اللهم عنا معهم أجمعين اللهم آمين. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد مجيد. We begin in the name of Allah, the most merciful in this life and in the hereafter, and we thank Him for all of His blessings that He has bestowed upon us, for they are innumerable. And we pray that we follow in the footsteps of Prophet Muhammad, peace be upon him, and his fellow companions. Amen. We also ask for prayers and blessings to be bestowed upon Prophet Muhammad, peace be upon him, and his family, as they were bestowed upon Prophet Ibrahim, peace be upon him, and his family. I found that I have some time before I pray Fajr, which is the prayer before dawn. So I thought I would continue with the lecture or the sub-series for dynamic arrays, because alhamdulillah, thank God, I slept last night rather well, or at least I hope so. So I am energized now and ready to continue with recordings. So before we move on to the diagrammatical representation of the array, because it is finished, wait, I wanted to check. Oh yeah, I have it here. Never mind. Okay. Just wanted to check that I have this line. I thought I missed it last time. So I will show you how to use the string class if you are interested. String is equal to an empty string. So it is basically the same as this, but without the need for the toString method, of course, because this is a string, not a string builder. So I will return these to compilation, and I will edit these, of course. So string is plus equal array I plus comma space. And as I mentioned in the previous video, this is a compound assignment for the concatenation operator, not for the addition operator. And there is no need for this. And this will, actually it will, it will be equal to string. Oh, sorry. So it will be this plus the string like so and like that. And there is no need for this. Let us test this. So we have, let us return these to compilation and let us test this to see if it will print without the comma and the space. Perfect. Now this, unfortunately, if you wish to print that the array is empty, this will not function properly because the array will always be full regardless. Why? Let us take a look here and remove these from compilation. It is still occupied with zeros. So you cannot have this portion will never be reached in the code. That is why it did not work with the string builder class. I thought it was, well, at least because I was a bit tired, I did not think clearly. I thought it was an issue with the string builder class, but it is not. So I will return this to compilation because I prefer this since it is only one line as opposed to multiple lines. So now let us design an array programmatically here, and then we will represent it here so that it hopefully becomes clear. So I will set the capacity to 5. I am actually contemplating, you know what, I will use 3. That way it is easier. Okay, so let us add an element. C.addition, and I will add 1. Perfect. So I will print the current array so far, just to show you that, just to confirm that it has been added properly. Perfect. Okay. Now let us visualize the addition here. So we will return to the addition here. So now the array is set to the capacity of 3. So I will create 3 blocks like so. So this is the heap memory. And here we have the 3 empty blocks. So before this, before the element is added, what is occupied currently? The null values. So we will add these here, then we will change them later. So we have 0, then we have another 0, and then we have the third 0. Perfect. Okay. Now let us see what happens when we actually add 1. So we have a 1 here that we need to add. So let us return to the code. Firstly, is the size greater than or equal to capacity? The size is currently 0 because the array is empty. Even though it is full with nothing but zeros, these are not considered part of the size because they are null values, so we do not wish for them to be considered as part of the size. So here the size is not greater than or equal to capacity, thus this if statement will be skipped. Now let us move on to this line. Array at the size, index size, will equal to element. What is the current size now? Here, I will write it like so. Size is equal to 0. Currently, this array has a size or a length of 0. So what does that mean? Here, this will be array of index 0 because the size is 0. So if we substitute size here with a number, with the current size number, it is 0, especially since we did not initialize it. Thus, it acquires the default value, which is 0. Addition, yeah, is equal to element. And what did we pass here? We passed 1. So basically what we are saying here is this. At the last element, which is the beginning here, you know what, I will move this, I will pull this downwards and add the indices or indexes here for convenience. So the index is here is, the index here is 0, the index here is 1, and the index here is 2. So now the maximum size is 0. So at the index where the size is maximum, place 1 into the array. So here, this index is 0. So this 1 will be transferred here like so. I will keep this 0 here in case I need it for later to expand the array. Now what do we have to do in addition? The size will be expanded by 1. So we will add 1 to this. Why? We do not want to factor the null values. We want to factor only what we add. So these 2 zeros do not count as the size of the array. However, if you do add a 0 here, this will be considered part of the array. Why? Because you are passing it through the addition method. But without this, the zeros that we printed here, these zeros, they are not part of the array. They are simply occupying a place in memory, because you cannot create an array without a static size provided. So you merely provide the default size, add whatever you wish, and the rest will be occupied with zeros until you decide to change that later. So we wish to add this element as part of the size of the array, because the size is currently 0. So you must increment it here. So now the size then increments by 1. So now the new size is equal to 0 plus 1, which is equal to 1. So this is the new size, which matches what we added. We added only 1 element, thus the size is 1. This will keep repeating, of course, when you keep adding elements. So let us say I wish to add the element 2 to the array. So what happens here? Is the size of the array greater than or equal to capacity? Size from the previous addition is 1. Now the size is 1. Is it greater than or equal to capacity, which we set to 10? No, it is not greater than or equal to capacity, so this is ignored. Array at index size, or the current size, which is 1. So I will prepare the 2 here for addition. I will just keep it here for now until we need to add it. So array at index 1 now, because that is the new size, is equal to the element that we passed, which is 2, because it is part of the argument here. Once we do this, then the compiler adds, okay, that is a bit too wide. Then the compiler adds the 2 here, and the 0 is removed or changed. Its value is changed. And of course, because we need to factor in the newly added number, we will simply increment the size by 1 again. So the size will be 1 plus 1 is equal to 2, which matches the number of valid entries we have. This is a null value. You know what? I think I will use the null value in red just to remind the viewer that this is a null value. It is not factored into the size of the array. Okay. This of course is an index. So now let us insert a value, and then we will reach full capacity and we will see what happens afterwards. So I will keep this because this has the new size in it. Now let us insert a value. I wish to insert a value here. So what does that mean? It means that I need to push this 2, because remember, this 2 is part of the array. So I do not wish to delete it. I wish to insert a value at its location, which means that I need to shift it here, create an empty slot for the newly inserted element. So I need to shift it to the right. So in insertion, we always shift to the right. For deletion, we shift to the left. So in insertion, you want to create an empty slot. In deletion, you wish to close that empty gap. So you shift to the left. So let us insert a number at this index here. So I will insert the number 3 at index 1 and the number 3. This is the element that I wish to insert. So I will print this just so that you can see what we have. 1, 3, 2. Perfect. Now let us return to the code and see what happens. So now I wish to iterate through the array until I identify the required index or the required position that I need to insert the new element into. So I will prepare the 3 here for when we need it. So I will leave it here like so. And I will also copy this in case I need it for later, so I do not forget. Now let us return to the insertion here. So since I need to iterate through the array, I will need a for loop. We will start with int I is equal to size, and we will end at I is greater than the index that we passed, and we will decrement. So we will start from the end of the array, move towards the beginning of the array, so we will have to decrement. What is the size here? Remember, the size is currently 2. So if I is equal to 2, we will start here. This is our starting point. So this means that I is equal to 2 and I is greater than, so this is our starting point in the for loop, this for loop, and our end point is I greater than the index we passed, which is 1. So I is greater than 1. Remember, it is not equal to, it is just greater than 1. You will see how this plays a role. So I will leave this here and I can start, I can continue with the algorithm here. Okay. Now let us return to the algorithm. Array at the index through the iteration, of course, is equal to array index minus 1. So we will start with size, which is 2. So let us write this with the information we have. I is equal to 2 currently because the new size is 2. So let us write this in here. Array at index I is equal to array at index I minus 1. So let us substitute I with 2, like so. So what does this equal? 2 minus 1 is equal to 1. And I forgot the A here for array. So what does this mean? This expression. The element within the array at index 1, which is what? 2. Put it at index 2 of the same array. So basically we are informing the compiler to shift the element from index 1, as you can see, to index 2. So we have shifted it to the right. So this, I will highlight it here, to shift elements to the right. Then I would decrement, so I would move from 2 to 1. 1 is not greater than 1, so the for loop ends. because remember this is 1 here, and this became 1 after the decrement, so this ends. Of course, it would not end if the array was larger, and for example, you had at index 15 here, and you wanted to insert at 1, it would keep decrementing until it reaches 1. And as it is decrementing, the elements are being shifted one by one to the right until this is reached. Okay. Then after this completes, we have this equation, or to be more precise, expression. Let us write it here and see what we have. The array at the index that we passed as an argument, not this. Remember, this is within a scope, so you cannot access it beyond the scope. This refers to this, is equal to the element we passed. What is the element that we passed? It is 3. And what is the index that we passed? It is 1. So now I am informing the compiler. This of course transforms to 0 when it is shifted because it is a null value. I am simply leaving it empty for visual representation, just to show that we need to insert the value here. So the compiler will take the 3 and insert it or assign it to the first index of the array, like so. And since I added a new number to the array, we need to increase the size of the array. So the size here would be size is equal to 2 plus 1 is equal to 3. So now the new size is 3, which matches this. So now we have 3 numbers. Okay. Now let us test the expansion, and then we can test deletion and possibly shrinkage if we are able to adjust the capacity properly and correctly. So let us test the expansion now. Where is expand? Yeah, there we go. Okay. So now the array is full. What if I wish to add a 4th number? So I will keep 4 here. This is what I wish to add. Remember, in addition, you add at the end, and you will see how it functions in a bit. So what happens when I add this line to the code? Let us test it. Is the size greater than or equal to capacity? Well, what is the capacity? We set it to 3. It is not 10. I probably mentioned 10 initially, but when the size was 0, this was 3. So I apologize for that because I forgot that we set it here. So the size, which is 3, is greater than or equal to 3. So we need to expand before we add. So what happens in the expansion? We create a new capacity, or you can simply multiply the current capacity by 2. Then we create a new array. So what I will need to do is I need to copy it. Perhaps I can push this here since we do not need it anymore, and pull this upwards like so, because I will need the room for the deletion algorithm, and I will create a new array. Perhaps I can use the light green. Oh, no, that is too bright. I will use brown for the new array. is 1, here is 2, and here is 3. But we will not stop there, of course. So firstly, we need to calculate the new capacity, which is 3 times 2, so that is equal to 6. And then we need to create the new array with 6 slots. So I can simply copy these 3 and paste them like so. 1, 2, 3, 4, 5, 6. So now we have created the new array. So as you can see, it is tedious to expand a dynamic array because you have to create the new array, then copy the old array into the new array, and after it has been expanded, copy it back. It is time consuming. So let us copy the array. We will ignore this method or this algorithm because it does not show us the steps. So we will instead refer to this. Even though it is part of the shrinkage, it is used in the same manner. So again, because I need to copy this entire array into here, I need to iterate through it initially and then copy each element as I iterate through it. So we will need a for loop. I is equal to 0. I is less than size, which is currently 3, because we have 3 numbers, and I++ to increment upwards. Now let us test this and see. So I can use this color. New, oh, that is too bright. New array at index I is equal to array at index I. So we will start with 0, as you can see here. So we will substitute these with 0. And this, of course, mirrors the index here. So this is the 0th index, the first index, the second index. We are informing the compiler here the element at index 0 of the original array, place it at index 0 of the new array. So what is the element at index 0? 1. Place it into the new array like so. And then increment I by 1. So the new I will be 1. So we will remove this and remove this and add the new index because of the incrementation in the for loop. Check this upwards like that. Perfect. So what is the element at this index? It is 3. Place it at the same index like so, and then it will increment, and finally we will have the same here, and it will stop at index 2 because remember, I is less than 3. I is less than 3 here. So what is less than 3? It is 2. So it will stop here. And the new array has been created. Now remember, this 0 and 0. This is the source position in this method, source position 0 for this array. So start copying from here. If you change this to 1, for example, you want to start copying from here instead of from here. That is basically what it means. And copy it into the new array. Where do you want to start copying? Again, from 0. So that is the destination position, and you pass in the size. Okay, let us return to the algorithm here. Now, after the array has been copied, you assign the new capacity to capacity, so change it from 3 to 6, and then, because remember, this is a temporary variable or a local variable, we need this to actually contain the new array or the newly created array so that it expands and we can manipulate it later on. And then place the new array, or rather the pointer of the new array, assign it to the pointer for array instead. So now the object or the pointer of the old array is now pointing here instead of pointing here. So if we create a quick diagrammatical representation of the stack, I am accustomed to using this color, and we have the object known as array here, and it used to point at let us say 317, which is this memory block, or at least I want it to be this memory block. It does not matter what number you add. This is simply for demonstrative purposes. So it will point at, remember, when you create a pointer for an array, it always points at the first element of the array, which is 1 here. I will delete this. I will delete this. Perfect. With this line, so I will write it here for you. Array is equal to new array. What we are telling the compiler is to have the pointer instead of pointing here, we want the compiler to point here for this new pointer instead, like so. And this, of course, is removed from memory. It is deleted from memory, and now we have a new array. So this is what we currently have now, like so, and like, that is too wide, like so. Extend it a bit. There we go. That looks hideous. But one does what one can. Push it upwards like that. Okay. So that is what happens. So you create the new array so that you have a pointer or a memory address that this new that the instance variable array can point to, and of course we will change the memory address because this was created at a new memory address. So let us say the new memory address is 1444, our new Islamic year, because I do not care about the Gregorian calendar. So now we have a new pointer. So the old array that was copied is deleted from memory, which we will cover in garbage collection bi'ithnillah and God willing, do not worry. And now we have a new array to use. So the old array is deleted, and now we have a new pointer. And thus the array has expanded successfully, and of course it will have the null values, which are 0 for numerical variables, and false for Boolean, and lastly null for objects, because null is analogous to 0 but for objects. Okay, so that is perfect. And now then this will occur. So array size the size is now 3. So we do not need this anymore because that is part of the expansion. So let us actually cover the addition again, because we need to add the 4 here. And I should add the indices or indexes to avoid confusing anyone. Drag it like so. You know what, I'll just put it here, and then we have 4 and 5. Then I will drag them like so. 3, 4, and 5. Perfect. So now we cover this. Let us use this color. Hopefully it will be it will not be bright. Array. Okay, that is too invisible. Array at the current size, which is 3, is equal to the element we passed, which is 4. So now the compiler simply drags this and places it here, like so. And because we want to factor this into the new size, we will increment by 1, so that we tell the compiler the number we added is not a null or a default value, it is a valid value or part of the array. Because you can add a 0 if you want to your array, so you have to differentiate between the default value 0 and the actual value 0. So size will be equal to 3 plus 1, which is equal to 4, and that matches what we have. Lastly, let us cover deletion. So I will remove this, or not remove it, but lower it here, like so, so that we can cover deletion. Let us say I wish to remove or delete this value. So I wish to remove it like so, which means I have an empty spot here, so I need to shift these like so, and of course this will be removed as well. Okay, so let us try deletion. Okay, let us return to the code here and find the deletion. There we go. Again, since we wish to delete, we wish to find the element that we wish to delete, so that we have to iterate through every single element until we locate the element that we seek. You can also code this so that you identify the index at which the particular element needs to be removed. You can code it that way, but normally for deletion, you designate the element that you wish to delete. So we will delete 4, like so. Now let us print this just to see. Well, firstly, because we did not test it with this, let us see what the array would appear to be. It matches what we have in that diagram. 4 numbers and 2 default zeros. Now I will return this to compilation and execute once more. And there you have it. The number has been deleted and the empty spot was replaced with a 0. Perhaps if we delete one more number, we can see shrinkage being executed as well. So we can try deleting another number just to see what happens here. Okay, so let us test this then and see what happens in deletion. I is equal to 0 and I is less than the size. The current size is 4. So we will have the following. I is equal to 0 and I is less than 4. So this index here. Okay, now let us iterate and see what happens. If the element is identified, because remember, if you set for example, delete 5, we do not have a 5 in the array. So the element will never be found. So you could circumvent this by having else like so, and say element does not exist, just as an example. So let us test this and see. No, element does not exist. But it copied it multiple times because of this. So if I could, yeah, but you have seen what I wanted to demonstrate. But let us see what happens if I wish to delete 5 without anything. Nothing prints. So you can have it print an error message, or you can leave it as such. Normally, that error message that I showed you is used for the searching method, which we will cover later bi'idhnillah and God willing. If you enter an element that does not exist, then the search method should inform the user that the element you are searching for does not exist. Okay. So if the element is identified, if I at a certain index is equal to element, so let us write this just to see, just to try and visualize it. If array at a certain index is equal to the element we passed. What is the element we passed? We want to delete the 4. Oh, I should probably change this to 4. Or actually, let us delete the 2, this one, so you can see the shifting properly. So let us change this to 2. So the element that we seek is 2. 2 is at index, oh, it is at index 2. So through the iteration with the incrementation, I will start at 0. It will not find the element. Then it will increment to 1. It will not find the element. Then it will increment to index 2, and it will find the element. So the element designated for deletion has been found. What do? Well, we create a new for loop. So this is to find, oh, I need to comment. To find the element, and this is to delete element through this line, of course. Now let us write this. J is equal to 0. So that is simple. Alhamdulillah and thank God. 0. There we go. And J is less than size minus I minus 1. J is less than the size minus I minus 1. What is the current size? The current size is 4. So we will replace this with 4. And what is the current I? After iteration, I stopped at 2 because of this if statement. So I is currently 2 now after iteration. So we will remove this. Probably should drag the minus here and remove this and add 2 like so. So now we have 4 minus 2 minus 1, and the direction of associativity here is this direction. So it will be 4 minus 2, that is 2, and then 2 minus 1 is 1. Remember, it is not 2 minus 1 is 1, and then 4 minus 1 is 3. That can cause confusion. If you ever forget the associativity of an operator, you can either refer to the sheet I attached for you in the operator precedence lecture, or simply test it. You can test it easily by doing this. do not, let us delete it, who cares. 4 minus 2 minus 1. So this should equal 1. There we go. Perfect. Okay. So yeah, if you ever forget, just simply print it and test it. So this is equal to 1, like so. Okay. Since j is less than 1 because it is 0, what should the program accomplish? We have this line here. Array at index I plus j is equal to array I plus j plus 1. So let us type this. Array I plus j is equal to array I plus j plus 1. What is I? Currently I is 2. Now, after iteration, I is equal to 2. So we will substitute this with 2. And j is currently 0 because this is the first iteration, so we will substitute this with 0. Again, we will do the same here and here. Oh yeah, there we go. So 2 plus 0 is 2. 2 plus 0 is 2. Plus 1 is 3. What is the element at index 3 of the array? It is 4. Place it into the second index of the array. So take the number from this compartment, place it into this compartment. So the compiler will do this. Like so. This is what we did currently. Then j will increment to 1. 1 is not less than 1, so the for loop will exit. Now let us see what this does. Array is equal to size minus 1. Because now we have 3 numbers, this does not match. This is incorrect. The size is still 4. So we need this line here to fill this empty gap with a null value. So let us say array size minus 1 is equal to 0. Remember, this is the null value, so that we place this here to fill in that gap. If it was a Boolean array, you will add false. If it was an object array, whatever the object that you are using, if it is a string class or a customizable class, you will simply add null here to fill in the gap. So we will use 0 because we are using an array of integers. What is the size? Size is currently 4 minus 1, so that is 3. So place a 0 or a null value at index 0. So we will do this like so. So that way we fill in the gap. Then lastly, we will break out of this loop because we do not wish to continue iteration anymore. We found the number at index 2. There is no need to iterate through 3, 4, and 5. Now, just to check what happens, let us print the size of the array to ensure that we have a size of 3 now. After deletion, oh, we have 4. So that means there is a mistake somewhere. Now let us check and see where the mistake is. I believe I know where it is. Let us see. Yeah. Okay. There we go. Now let us test this and see. Okay, this is perfect now. So I forgot to add the size decrement here for this. Size is equal to 4, because this changed the index only, size minus 1 here. It did not change the actual value of size. Minus 1 is equal to 3, which matches the number that we have here. Perfect. Now let us test shrinkage quickly by deleting yet another number. So we will delete 4 as well, and hopefully that shrinks the size. Oh, that still does not shrink it. Okay, let us try deleting 1. Oh, it does not shrink it. So the problem with shrinkage is that we have a threshold that is never achieved. That is the problem. Oh wait, where is shrinkage? Sorry, not shrinkage. Where is deletion? Oh, okay. I just realized my mistake. I apologize once more. Well, thankfully we have different episodes for this sub-series. I forgot to add the shrinkage method in deletion itself. So if size is less than or equal to capacity, sorry, we will add the threshold here. And I do not know why I opened the square brackets. There we go. Capacity divided by 2. So it is 6 divided by 2. That will be 3. So if the size is less than or equal to 3, shrink the array. Like so. Okay. So let us test this again. Do not need to delete. I believe this should suffice. After deleting 4, it should shrink it. Perfect. So let us test the shrinkage now. So we have 6 slots, and the size is currently 3. So when we designate this for deletion, this if statement will come into play. Is the size, which is currently 3, less than or equal to the capacity, which is 6, divided by 2? Yes. Shrink the array. How do we shrink it? The same as what we did before. We will create, let me just pull this downwards because I do not need it anymore. We will create a new array, like so, but with a new capacity, so 6 divided by 2, so it will only be 3 slots. So I will create the 3 slots here. There is 1, there is 2, and there is 3. There we go. Okay. And then it implements the same process as with expansion. It will start copying the elements as it iterates through them, like so. Copy this, and of course, since this was deleted, I should remove it and add this. and copy the last number, which is this. Come on. And then it will create a new pointer and assign it to the old array through this line. These are pointers, these are not values. These are this is how you copy values of an array. These are pointers, remember, or references, as we have discussed in the past. And let us say the new one is 900. So that was the number of Muslim soldiers in the second main battle in Islamic history, Uhud. And then the new pointer will point towards the new array like so. This old array will be deleted from memory, and this new array will come into play like so. And let me see if I can rectify this. There we go. And that is it for dynamic arrays. I hope this lecture was helpful and beneficial to you all. Enjoy the rest of your day, everyone. Be safe, take care, and peace be upon you all. والسلام عليكم ورحمة الله وبركاته. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد